So chapter 5 is about linear correlation. Correlation measures the linear relationship between two quantitative variables, so between x and y, for example. Now the Pearson correlation coefficient measures the strength of the correlation between two variables. We use the lowercase r to denote the Pearson correlation coefficient, and it's always between -1 and +1. Now the sign of r, whether positive or negative, indicates the nature of the correlation. So if it's going up to the right, it's a positive r, and if it's going down towards the right, it's negative. If r equals 0, that means there's no relationship, we can't see any pattern. If r equals +1, there's a perfect positive correlation. And if r is -1, it's a perfect negative correlation. The further r is from 0, the stronger the correlation there is. Here's what we'll be using for this class, although there's no real hard and fast rule for all statistics. It's just kind of generally close to 1 or -1 is strong, and close to 0 is no correlation. So the first one, if the absolute value of r is between 0.85 and 1, there's a strong correlation. If the absolute value of r is between 0.5 and 0.85, there's a moderate correlation. If the absolute value of r is between 0.1 and 0.5, there's a weak correlation. And if the absolute value of r is between 0 and 0.1, there's no apparent correlation. In order to calculate r, there are two options. So for a set of n data points, so we have 1, 2, 3 data points that are given as ordered pairs, x1, y1, x2, y2, x3, y3, etc. We can calculate r with the sum of zx, zy divided by n minus 1 with n minus 2 degrees of freedom. So let's go ahead and calculate. Now calculating x bar and y bar, those are just the means. In tiny print here it says rounded to 4 decimal places. So let's go ahead and calculate. There are a couple different ways I could do this. I could find the mean of x by adding the x values and dividing by the number of x values I have, and then the same for y. So I can fill out my worksheet. X bar is, where the mean of x is -1, and the mean of y is +2. In order to calculate the standard deviations of x and y, I'm going to go through several steps here. So first, we want to calculate x minus x bar for each x value. So we've pulled all the x values down here. 3 minus -1 would be 4. -1 minus -1 is 0. -5 minus -1 is -4. Then I'm going to square each of those. So I have 16, 0, and 16. Remember, you square the negative sign. And then I add them all the way down, 32. So that is the numerator there under the square root. I have all the x minus x bars squared, and then the sum. Now I have to divide it by n minus 1, and then take the square root. And so remember we said we have n equals 3. I'm going to just make note of that here. So that means n minus 1 is 2. So 32 over 2, and then square root of that will give us the standard deviation of x. So 32 divided by 2 is 16. Square root of 16 is 4. Now I'm going to do essentially the same thing for y. So -4, 1, and 9 are the y values from those points, and I'm going to subtract the mean of y. -4 minus 2, -6, 1 minus 2, -1, 9 minus 2, 7. When I square each of those, I get 36, 1, and 49. I add those up, I get 86. And then if I take 86, divide by n minus 1, which is 2, and then take the square root, I get approximately 6.5574 to 4 decimal places. Now before we continue, I am going to show you really quickly how to do this in the calculator. If you hit Stat, which may be in different places on your calculator depending on what calculator you have, when you hit Stat, you have a menu. So I want to edit, and if you have anything in your lists here, I clear them. But I want to put in the L1, I want to put the X values, and then in L2 the corresponding Y values. So 3, -1, and -5. And then in the L2 list, I have -4, 1, and 9. So then if I hit Stat again, instead of going to Edit, number 1, I can hit my right button, my right arrow, and go to one variable statistics. So if I want one variable statistics and I just press Enter, by default it's going to give me the one variable statistics for X. So it gives us the mean of X, the sum of all the X's, the sum of X squares, the standard deviation of X, and we want the S because it's a sample. It gives us how many X values we inputted there. And it also gives us our 5-number summary: min, Q1, median, Q3, and max. So that's kind of nice. And then to do the same thing but for our Y values, we can go stat calc one variable statistics, and then I need to specify that I don't want that first list by default. So if you look somewhere on your calculator, you're going to have L1, L2, L3, etc. So on the TI-84 Plus, L2 is in blue above the 2, so I need to use second 2 to specify. Second 2 gives me that L2, and then I press Enter, and it gives me the same statistics, but for Y. So it gives me the mean, sum of X squared, standard deviation 6.5574 approximately, gives us N, and the 5-number summary. So that's a good way to check your work. So the next step would be to use the rounded values from above, find the z-score for each X and Y value, then round each z-score to 4 decimal places if necessary. Remember that the z-score is calculated by using X minus mean over standard deviation. So mu and the sigma, lowercase sigma, are mean and standard deviation of the population. However, when using sample data, this translates to X minus X bar over S. So when we're calculating the z-score for the first X value, I'm going to just show my work a little to the left here. Z of X1 is the X value 3 minus the mean. In this case, our X bar, remember, is -1. Then over the standard deviation, which is 4. Okay, I'm going to go ahead and set up all of these. Z sub X2 equals -1 minus -1 over 4. And Z sub X3 is -5 minus -1 over 4. So then when I simplify each of those, I have 4 over 4, which is 1. -1 minus -1 is 0. 0 divided by 4 is 0. And then -5 minus -1 is -4. Divided by 4 is -1. Now when I'm calculating my z-scores for my y values, it's the same idea, except I use the mean of y and standard deviation of y. So -4 minus 2 over 6.5574. Z sub y2 is 1 minus 2 over 6.5574. And then Z sub y3 is 9 minus 2 over 6.5574. When I simplify each of those, I must admit I will have to use a calculator here. I get -0.9150, -0.1525, then 1.0675. Now when you're doing these calculations, whether you're using your calculator or RStudio, make sure that you're using either parentheses like parentheses -4 minus 2 close parentheses divided by 6.5574, because remember, if you do it without parentheses this way, you'll get a different answer. So either that, or you can use a fraction to do the same calculation. Each row you're going to multiply the z-score for the x with the z-score for the y. And then you take the sum of that column. So negative 0.9150 plus 0 plus negative 1.0675. So that gives us negative 1.9825. Okay, so now we have the sum of zx, zy, which is the numerator there, divided by n minus 1. So that looks like negative 1.9825 divided by, and we have 3 ordered pairs, so we divide by 2, and we get approximately negative 0.9913 rounded to 4 decimal places. So that's one way to find R. Let's try a different option. So option 2 to calculate R is to use this SP, which is sum of products. You can see that we have a sum of products, xy, minus a product of sums, sum of x times sum of y all over n. And then find R. So we're going to use that sum of products in the numerator and then divide by n minus 1 times standard deviation of x times standard deviation of y. So we're going to use this table to do so, and we just multiply across for xy. So x is 3, y is negative 4, xy is 3 times negative 4. Negative 12. And then we have a sum of x's, sum of y's, and the sum of xy. So when we add 3 plus negative 1 plus negative 5, we get negative 3. Negative 12 plus negative 1 plus negative 45 is negative 58. And then when we multiply the sum of x times the sum of y, and sorry about that weird parentheses there, we get negative 3 times 6, which is negative 18. So then to calculate the sum of products, sum of xy is negative 58 minus sum of x times sum of y, which we have as negative 18, over n, which is 3. And that simplifies to be negative 52. Now, using the standard deviations of x and y that we calculated previously, we can multiply standard deviation of x times standard deviation of y, rounded to 4 decimal places, is 26.2296. And then we can plug everything into our formula for R. So sum of products, negative 52, over n minus 1 is 2, times the product, 26.2296. Negative 0.9912. If you recall, in option 1 we got negative 0.9913, so it's only off by a 10,000th, I believe. And that's pretty good. That's really close. Pearson's correlation coefficient tells us information about the relationship between our x and y variables. Using the value that we calculated, negative 0.9912 or negative 0.9913, those are both pretty close to negative 1. So we would say that that's a strong relationship. It's a negative number, so it's negative. And it's linear. Right now we're only doing linear. So it's a strong negative linear relationship between the x and y variables. And the coefficient of determination is the percentage of variation of the y variable that can be attributed to the relationship. So we use r squared to calculate it. It explains the percentage of the variation of the y value that can be explained by the x value. So the dependent variable based on the independent variable. So r squared is just negative 0.9912 squared, which is approximately 0.9825 rounded to 4 decimal places. And r squared should always be positive because we're squaring a value, which means if we convert that into a percentage, approximately 98.25% of the variation of y can be explained by the variation in x.